I have demoed EVM interpreters, smart contracts before, and I have demoed various precompiles before, including the EVM Interpreter Precompile that we are talking about today. We started from this type of precompile that I implemented in my macro assembly language, which translates it in pure EVM assembly. And I have presented you various flavors of EVM interpreters, each with a different approach on how they handle reading and writing in storage, emitting events, or analyzing the interpreted bytecode. But these interpreters, even if they were maximum efficient as computation and gas, they were still costly. But the most important problem was not gas. It was the fact that the EVM, through the Ethereum yellow paper, enforces bytecode analysis of valid jump destinations prior to executing the computation. This adds overhead to the on-chain bytecode interpreter. And even if there are in-work proposals to make the EVM better in this respect, in reality, changes are slow to non-existent. So the elegant solution would be to integrate this EVM interpreter as a core precompile in the EVM. This is the most efficient way. And I will show you a short demo, and then we will talk about why is this EVM Interpreter Precompile so important. I have implemented this EVM interpreter in Go Ethereum based on my branch that proposes extending the functionality of precompiles. And I am running a local Geth node modified to support this precompile. So here I have a dApp with all the functions that I implemented for the EVM interpreter and analyzer. But today I will show you only the interpret function. This is the address of the EVM precompile. We have MetaMask connected to our local modified Geth client. And now what we need to test the interpret function is the runtime bytecode of the smart contract, call data, gas, and value in way. And the result of the computation will be returned. So within the EVM, you can interpret EVM bytecode. This is a very short smart contract bytecode that also contains the constructor, and what it does is just take this value and return it. So we will take this bytecode, the call data is empty. Let's put some gas here and a value of 0. Interpreting this bytecode should give us the runtime bytecode of the contract, which is the bytecode that will be saved by the chain itself. So now we can interpret this runtime bytecode, and we should get that value with 222. And we get it. So why is this important? With an EVM interpreter precompile, the EVM becomes more flexible. It can change how contracts are stored and used, how individual functions are stored and used. It is the most flexible contract and a tool to upgrade behavior. You can test code by using the mainnet global context, and it should become the criterion for pre-production testing. Instead of trusting testnets or off-chain sources of truth, we can have a standard source of truth, the same that will eventually interpret the contracts. You can also add multiple types of EVMs to be tested in production without affecting the actual base layer. And just by having this EVM interpreter inside the EVM as a precompile, you can have native and efficient mechanisms for layer 2 solutions like rollups. And this can be made possible by opening up the EVM precompiles to have the same rights and information context as normal smart contracts.